Working on a 2007 Chevy Trailblazer with the 4.2 engine. Issues this one, it has a really weak crank. I believe it's due to the battery. Weak battery. So we're going to do some real quick checks on it. And show you that what I check for. Make sure the charging system's working correctly. But I'm going to try to start it here. If it sits overnight, I already started it once, but if it sits overnight, it'll barely even start, if it'll even start. So you can hear it's very weak right there. If you look, the charging voltage it's really high right now because the battery is weak. So I'm gonna go ahead and shut it off. But if you heard it there, I don't know if the video captured it, it barely cranked. And it's not that cold in here. It's probably like 40, 50 degrees in this garage. But when it gets down to single digits or teens, this thing, it won't even crank. It'll just click, right? So what I want to check for is to make sure the alternator is working correctly, charging. There's no parasitic draw on the system. Check the battery. Battery load test it. But it looks like it's a battery, but I'm just going to show some of the stuff that I check for so we don't, throw parts at the job, and we'll go from there. We'll try to start it one more time after it sits a little bit, see what it does. You can try to listen to it again. So again, it's pretty weak. So now what I'm going to do is I'm going to hook up, you can use an oscilloscope. The reason I'm using an oscilloscope is so I can hook my amp clamp up and read amperage. You don't need to do all this, but depending on what kind of fault you have or charging system you have, you may want to do that. But you can also use just a regular DMM too, digital multimeter. But we're going to hook up the oscilloscope and do some checks. So I got my leads, battery positive, battery negative. There's a little corrosion on those connections, so I cleaned all that up. But to get a good reading. So you can see the waveforms all over. It was, if I pause this. Why was that all over? Because it was running and then I turned it off and then modules were turning off there. So right now everything's off. Still a little bit all over because module's turning off. But if I bring my cursor down and I put it right on there, I got, looks like 9.8 volts, 9.810 volts roughly. That's very weak, right? That's why it barely starts. I'm surprised it doesn't even start. It's supposed to be 12.6 volts because there's 6 cells at 2.1 volts a piece. 2.1 times 6 is 12.6. That's a fully charged battery. So now what I'm going to do is go ahead and start it. Read the alternator output. Hopefully it starts again. So it's running. You see the alternator we're charging at roughly 14.25. It goes up and down. Hang on. Got cursor out of there. (14.6). There's a voltage regulator built in there. Obviously it's going to be higher voltage now because it's trying to get that battery back. It knows that, well, the battery's weak, right? There's also on these Chevys, they have an amp clamp from the factory that's built around the cable to check amperage going through. So the alternator is charging. You can see it just went up there. If I pause this, go back a frame, 15.15 roughly. It's not overcharging, it's just that battery's that weak. So it's charging, the alternator's working correctly, but what we're going to do now is we're going to go right after the alternator, go right off of the alternator post that goes to the battery, and we'll do a check there and see if we get the same results. Alrighty, so I got the negative lead on the battery, the positive lead on the alternator going to the back of the alternator. So now I'm going to hit play on the scope again. Actually, it is already playing there. So if you look now, I got, let me see where I'm at. 12.4. It's got a little surface charge on it from running, but we had like 9.8, 10 volts earlier. I don't honestly think it was that weak, because if it was, it wouldn't even crank over at all. I just think I had a bad connection on these connectors here. Now I cleaned it up more. I got a better connection, so. But it's obviously still weak for that battery. If you look at this chart here, 12.6 or greater is 100%, 12.45, which is what we were just at now, 75%, 12.350, 12.15, 25. So obviously we had 9.5, 10 volts, or 9.8, 10 volts. We would have, it would have never started. That was just because I had a bad connection, because there's a bunch of corrosion on this connector there, and you can see it. So we'll clean those up when we do all this. But now we got a better connection, so that's more realistic. So I just wanted to show that correction here, that before we had, you know, 12.3, 12.4 volts, obviously, so we could at least start the vehicle. But now, right now we have, yeah, 12.3. So obviously it is weak. So now we'll do the same test with it running and check the output voltage off the alternator. Let's go ahead and start it again. Go back over to the scope. Negative, positive leads hooked up, negative to battery, negative, positive to the positive post of the alternator. You can see there's some hash in there. We can put a low pass filter. Not really worried about that right now, but it's charging. You put an average right down that hash, you're getting 15.3 volts, which is kind of what we got earlier, 14.8, 15.15. The reason is the battery's so weak, I was trying to charge it back up. So we know the alternator's working correctly. So I went ahead and cleaned both those posts up some more with the wire brush. Everything's off, but now you can see it's actually reading correctly. I mean, the battery's weak, obviously, but if I put this cursor down here and line it up, we got 12. I just bumped it. Come on. Yeah, 12.17 roughly. Obviously the battery's getting pretty weak. Probably got a little bit of corrosion there too, but the battery's weak. So now what we're going to do is, we know the alternator's putting the right correct voltage out. We know the battery is weak. We can put an amp clamp on here just to see the amperage. Make sure that's reacting accordingly when you turn lights on and so forth. And then we can do a battery load check, and obviously we already know the battery's bad, but we can do some other checks. Depending on the charging system issues, this could help you identify some charging system faults. Alrighty, so now we're going to hook up the amp clamp. We just got a low amp clamp here. I got to go into my oscilloscope settings and pick here. We'll go to the, where'd it go? I'm trying to film and click on this. That goes up to 20 amps. We'll see if see if that's enough. We'll go to 20 amps. Hit play. It's at 0. Take our amp clamp. We'll turn the switch on here. Like stuck. So we went to the high setting, and then I'm going to hit 0 on here. That'll zero that out on the screen. And then we're going to take this amp clamp, go around that red wire down there, which is right from the alternator to the battery in the charging system, and check our amperage. All right, I put the amp clamp up here. It's had a hard time getting it down there. I mean, I can move some wire sheathing and stuff, but I put it up here because, well, what happens is the alternator charges the battery, you know, tees off, and it powers the power distribution center or the fuse box. So it's going to be the same readings, obviously. So we're just going to go off that wire right there. So I have to flip my amp clamp around only because of the way the current flows. So if you look at there now, I got average between 2 and 4, about 3 amps. It looks like powering it up. Now we're going to go ahead and turn some lights on. I did get the clamp position right off the alternator. I had to move some stuff around, but I got it to work. But I got the lights on, the heater on, the defrost on, the flashers on, put an electrical load on the system. And you can see our amperage is still not very high, but it's like 3, goes up to 4 sometimes. And then you turn everything off. It shows only 1 amp. So I'm going to have to take a look at this and see what's going on. If I got a alternator issue, or there's something going on with the alternator in addition to the battery, or I got an amp clamp issue. Well, the reason I had such low amperage is not because of the alternator, it's because I had my setup wrong. So when you go to your amp clamp here, and your settings in here, you go to your P for probe. There's a CC65, there's 2 of them, a 20 amp and a 65 amp. That's the small amp clamp I'm using right there. If you have a CC650, you go to 200 or 650. That's the bigger amp clamp, which I have right there. But what I did wrong is I set it up here in the computer correctly. So I'm using the 20 amp. I don't think it's going to draw more than 20 amps in my scaling. But on this, the first one is 1 millivolt is 10 milliamps. Second one's 1 millivolt is 100 milliamps. I need to set it to 1 millivolt 100 amps, or 1 millivolt 10 milliamps. But I had it set to this one up here. Thought I had, this has got to match that, basically what I'm trying to get at. So I had that set wrong. That's why the amperage was lower. Yeah, we could have done the math and all that, but now that I got it set right, so I'm going to turn this off. Before I went 1, 2, 3, or 1, 2 all the way up. But I need to go 1 up. And then I'll zero it again like I did before. Now we'll have the accurate reading. So let me put it back on there and do the same test again. We'll go ahead and start it again. Obviously this just proves if you have your equipment set up wrong, well, you could be chasing your tail. And we could have went after, I almost went after an alternator there because of if I had my equipment set up wrong, if it was really pushing that low of amps, I'd be like, well, that's why it's not charging the battery. But obviously I had my equipment set up wrong, so I should always verify, whether using a multimeter, DMM, or whatever you want to call it, verify everything's correct. It's the same thing with the battery pulse. They were corroded. You always want to verify your readings because you'll be chasing your tail otherwise. So we got all that fixed up. Started again. It's starting better now because we've been running it quite a bit. Got the amp clamp on there. And let me pause it. So you look, it went way over to 20 amps there when I first started it, the spike, but now we're average, 12 amps. I could put a measurement in here. Now let's take our time base, move it faster. So our average DC is 10 amps right now, right? So let me go ahead and turn the lights on and put a load on it. So right now, not much load on, we're drawing about 10 and a quarter amps, which is a lot better than I had before, just because I had my setup wrong. But so that's normal. So now let's put a load on the system, and that should increase. So I just turned the lights on, and if you look there, the amperage went up. We're at 13 and a half, from 10 and a quarter to 13 and a half. Now we'll turn some more loads on and see where we're at. Now that's the average, obviously. So now I have the blower motor on, the flashers on, the rear defrost on, but obviously I'm gonna have to rescale it now because this is telling me that it's going over my 20 amps that I have it set to. That's why it's not reading down there. So I'm gonna redo my amp clamp, put on the higher setting now. So I picked a higher setting, the 65. I'll go all the way up button's like sticking. I gotta fix that. There we go. And then I'll zero it. Run a 2 millisecond of division time frame, so it's hard to see if it's zero. But if you zoom in, it is zeroed. I hook the amp clamp back up. Already amp clamps hooked back up. And I'm on the higher scale. I got 50 amps on this side. But now we're drawing once it focuses here, 17 amps. Right? With the load on it. Now let me turn everything back off again, let the engine continue to run. I turn the lights off, the flashers off, the heater off, and the defrost off. And now we're back to focuses. About 9 amps. So obviously the demand is matching everything. So the alternator is working correctly. Obviously if you put more electrical demands on it, the more amperage it'll be. So that all checks good. So what I want to do now is, I know the alternator voltage and amperage is good. That's putting out, so the alternator's good. The battery's weak. We know that. What I'm going to do now is 2 more tests. A parasitic draw test to make sure there's no draw on the system when it sits overnight, and then a battery load test, and then that'll be it. So now I'm going to do a parasitic draw test. Doors are shut, the hood's open, but there's no light on this hood. And typically, the general data is no more than 100 milliamps for a parasitic draw. But most, if you go into the service manuals for vehicles, they say 30, 40, 50. I know, like Mopar for Jeeps anyways, it's no more than 30 milliamps a draw. Because if you have more than that, if you have an amp or half an amp, you can do the math for me and figure out how long it's going to take to kill your battery. So make sure there's no draw on the system. So you can unhook the negative battery cable. You can go with the positive, it don't matter. Just go in series. Just got to make sure you take your lead here from your DMM. You got to put it in the A hole. I think you'll never forget that saying. So there's amps, and then there's milliamps. I'm going to go to amps right there because there's milliamps. Because if it's more than those milliamps, 200 milliamps, it'll blow the fuse in here, which I've done. So I'm going to go to the 10 milliamp scale. Turn this thing on. Let me set this up and I'll show you how I set it up. Alright, so I got the positive. You could reverse the polarity, just give you a negative symbol on there, which don't matter for what we're doing. But positive off the cable. This I'm going to stick in that hole right there, so we're in series. Watch the ammeter. Gotta get a good connection. So right now we're drawing. Hang on. It's just moved on me. Let me reset this up 1 sec. Already got in there. We're drawing 3.2 amps. And it's going to go down. Still at 3 amps, but it'll draw down because why? It's like when we plug, it's like it's plugging the battery in. Modules are going to turn on and eventually they'll fall asleep and go dormant. 2.8 amps, 1 amp. So now we're at just keeps going down, 0.07, which is 70 milliamps right now if you do the math. So right there's 20 milliamps if you do the math. So right now 0.02 amps is 20 milliamps. So we're good, but we're gonna let it sit here for 10-15 minutes or maybe even more. Probably should do 20-30, make sure nothing's coming alive. But right now this is within the specifications. But if it stayed at 1, 2, 3 amps, that would be a problem. There'd be a parasitic draw. What would you do then if you had a draw? It's going up and down a little bit, but we're still within specs. If you had, say you had an amp, 1 amp draw, you'd go to the fuse box, pull a fuse at a time. So you pull number 1, it doesn't change. Number 2, it doesn't change. And so you pull you're down to the 5th fuse. You pull it, it changes. That's the circuit you'd want to identify and go after and see what's going on. But right now we're at 20 milliamps, so we'll let it sit here for a while. And make sure we have no parasitic draw. Alright, it's been about 25-30 minutes. We're still at 20 milliamps. Sometimes it goes down to 1 or 10 milliamps, 0.01 to 0.02, which is 10 to 20 milliamps. So we do not have a parasitic draw. That is good. Alternator's good. Only thing we can do now is we can battery load test the battery, but we already know it's weak. We can do that anyway. So this thing needs a new battery. we'll put a new battery in, and that'll fix this issue with this car for hard starting. Alright, it's been running a while still, and you can see that the charging voltage is going down just a little bit because it is charging the battery up, because it knows that it's weak. But I did plug a scan tool in too. There's no codes in here. I mean, obviously we had the battery unplugged and plugged back in, but if there's anything, it would have just been low voltage codes. The alternator generator is working as advertised. No parasitic draw. The amperage is good on the alternator. All that stuff checks out. Simply needs a battery. We didn't need to do all these tests, but it just proves, depending on what kind of issues you have for charging starting systems, well, especially charging systems, you could use these tools to identify different issues with your charging system. Alrighty, so if you look at this battery, it's a Duralast Gold. The sticker's from September 2014, so it's a 6-year-old battery. They're not going to warranty it because they only have 2-year warranties on these Duralast Gold batteries. We can do a battery load check, so we're just going to hook the battery load tester up and check it, and I'll show you what our results are. I expect it to fail, obviously. Alright, I got it hooked up, positive, positive, negative to negative. Trying to film and do this, hang on. So I'm going to hold. Yeah, I'm trying to grab this here. Let me reposition my camera. Alright. Maybe I can hold it this way. Positive to positive, negative to negative. Maximum 10 seconds. So right now you can read the voltage. Yeah, 12.3, 12.4 probably. But it should stay in the green when we do this check. So I'm going to simply hold this. Look, it goes right to weak. Not to bad yet, but it went to weak. It should. A new battery will stay in the green. That's why. I mean, it ain't bad yet, but it's very, very weak. See that? It's going in the bad. So obviously, this thing needs a new battery, and then that'll fix this cranking issue for this 07 Chevy Trailblazer. So that is it for this vehicle. Well, I know I said I was done, but I did get a new battery. This one's manufactured of October of 20. I said earlier it's a 2-year warranty. They're actually 3-year warranties for these golds. But either way, the other one was never under warranty. So we got the new one hooked up. We'll go ahead and start it. We can check our amperage again. There's nothing we really need to check because you can already tell by starting it if you listen here. A lot quicker crystal start time there, so that's good. Got my amp clamp hooked up. No loads on the system. About 9 amps there. It's leveling out. 8 1/4. It's a little bit less amperage because obviously it doesn't need to charge the battery as much because it's a good battery. 8 9 amps. So again, we can turn the load on. We'll just turn the lights on this time. You can see the amperage went up to 10 amps. It's going to equalize there. So that battery's good. Alternator's good. Obviously just needed a new battery. So now there's nothing else we really need to do with this vehicle. That is a fix for this vehicle. What we can check is what they call AC ripple. That's just if you had some alternator issues. Let me get that set up and I'll show you guys that real quick. So for the AC ripple test, we know we don't have an alternator problem, but you could use this test as well to see if your alternator is good or bad. We know this vehicle's fixed, but for the AC ripple test, lead battery negative, positive lead to the alternator. It's best to go off the alternator, not the battery. Have my scope set up to AC, so it's AC coupled. and I'm on a 2 millisecond division scale. And then what I'm looking for, and I'm on a plus or minus 1 volt peak to peak reading there. What I'm looking for is no more than 300 millivolts of AC ripple at 2,000 RPMs, electrical loads on, lights, heater, defrost, and so forth. Why? Because the alternator has a rectifier bridge made up of diodes. It's just a one-way valve. A diode is. It creates AC current, and then it goes through the diode, and it won't let any AC current go back, so it'll make DC. Well, if you have one of the diodes or a couple of diodes going back, you'll have AC voltage being pumped through the whole system, which can flicker your lights. Anytime you have a 2-wire sensor, whether it's a vehicle speed sensor or ABS sensor, such as a wheel speed sensor, that can mess with the whole system. This vehicle's good, but it's something I always check for. They do all these checks when you take it to a parts store. They don't have an oscilloscope. They're just plugging into a machine. They don't know what they're just telling if it passes or fails. But I've seen where people have taken alternators in and it says it's passed, but it's actually failed. They don't know actually what they're reading. They're just telling you if it passes or fails, what the machine tells you. They don't understand. Maybe some of them do, but they don't understand what is actually going on for the test. But this is showing what we're doing here. So again, battery negative lead, battery positive off the alternator, negative lead, positive off the alternator. AC coupled. We're going to go ahead and start it and look for AC ripple. Starts so much better. So there's my AC ripple. I'm not worried about these peaks here. I'm not worried about that noise or hash. I'm going to pause it here and get my cursors down. Just bear with me. I mean, that's rough there. Peak to peak, I'm right. 71 millivolts. 0.071 volts, it's just 71 millivolts. We say no more than 300, so obviously this is good. The real test would be to rev it up. So I'm going to go ahead and rev it up and check it from there. So I got the lights on, heater on, defrost on, and I revved it to 2,000. You can show it to rev it to 2,000 because the period time is a lot closer together. But again, peak to peak, we're only at 156 millivolts. 0.156 volts is 156 millivolts. So first cursor is that, second cursor is that. 0.096, 0.060, you do the math, you get 156 volts. So with the load on the system, 2,000 RPMs, we're only half is the maximum. So this alternator for the AC ripple is good. Nothing wrong with the alternator, obviously. We didn't need to do all these tests, but it's just tests that prove, or you can use it to troubleshoot different charging system issues. Obviously, this thing just needed a new battery. Again, we didn't need to do all these tests, but it shows you pretty in-depth methods of making sure everything else is good. Because the last thing you'd want to do is replace the battery when you have a parasitic draw, a bad alternator, so forth. So if you have a scope, you can do a lot of this in your own garage and figure out what's going on. So that is it for this video. This vehicle is good to go now.